Hello, this is Roger Hill of Wuthering Heights Consulting, and I want to give you a little briefing on an up-and-coming situation here with a fairly powerful nor'easter. The computer modeling this morning is deep in this intense area of low pressure that will be developing along the looks like the southeast coast, and then work up and hug the coastline and head up right off New Jersey and right a little bit south of New England. This will be favorable for us to see some snow, probably mixed rain-snow event. And the storm right now looks like it's also going to be packing some wind for parts of the East Coast which do not need this. First off, the current conditions right now, you can see there's an area of low pressure that's off of Nova Scotia. It looks like a little bit southeast of Sable Island. And what's interesting about this is that for this late in the season, this third day of November, it's been actually showing quite a bit of thunderstorm activity. I can show you that by showing you this over here. And this is the area of low pressure where the cursor is, if you can see this. And these are lightning strikes that are currently taking place off the coast. This has been this way ever since Sandy, actually the leftovers of Sandy and its broad southeasterly flow has been pulling in tons of thunderstorm activity, hitting parts of Maine early, and then eventually more toward into the eastern Canadian Maritimes, and then typically offshore. This is not that unusual. I guess what is unusual is this late in the season to see just as much of this taking place. But also note, over here off the coast of Prince Rupert Island, the vicinity, north of Vancouver Island, there's even thunderstorm activity off of British Columbia. That's a little bit more rare, although this is cold air cumulus and cold air cumulonimbus, and implying that this is some seriously cold air that's been occurring from the Gulf of Alaska. But what I really want to show you is the evolution of a developing nor'easter here. Take you right here, doing this on an iPhone. But this is basically Florida. Here's the eastern seaboard. Here's the state of Vermont, for example. This is Nova Scotia, the Canadian Maritimes. Over here is the central part of the country. We've got Mexico to the south. We've got California here. It's a little hard to see in this various depiction, but I want to call your attention to, there's your Gulf of Alaska low, and a pretty good jet stream that's blowing in right now. And that can be seen right here. As you can see, this very powerful jet stream blowing in. This is a lot of jet stream energy. It's going to be playing a role, and this is how it works. Okay, we're going to go through every 3 hours here and try to show you kind of an idea as to what's happening in the upper levels. This is at 18,000 feet, 500 millibars. Okay, we are looking at, this would be valid today, Saturday. You can see a departing area of low pressure right here, and this is taking off, so this is not a problem for us, although it has pulled down significant cold air. But we have a fairly significant ridge that's going to be building in. And that's going to be bringing us some real nice weather for basically Monday and Tuesday, election day. But I want to call your attention though right now is take a look at this broad ridge. This is what we call a plus PNA, or Pacific North American Ridge, in its positive phase. Basically when it builds up, it forces the jet stream flow to then dig down, and it's this shortwave trough here that's going to be carving out the mean wave trough and be the supplier of jet stream energy to spin up a pretty significant nor'easter, an early season nor'easter, and something that New York City and the folks around New Jersey down into the Middle Atlantic do not need at this time. The shortwave trough, as you can see, is starting to move through the Ohio River Valley. It's right here. This is depicted as what we call upper level vorticity, positive vorticity advection, and anything you see in the yellows here is upward vertical motion. So vertical motion, it goes upward, produces clouds and precipitation, hence foul weather. Sinking motion is that darker purple area, high pressure, a lot of sinking motion. But you can have a combination of the two. But take a look how this jet stream energy then digs and goes out off the coast here. But another one basically digs along its back side. This is the lead impulse. If this lead impulse is fairly weak, this will take most of the energy, and indeed that's what happens. Now the overnight model runs have shown that this spins up a fairly significant storm in the vicinity of Florida here. The time would be, this would be valid 21Z Tuesday, so we're talking 5 p.m. Tuesday, so election day. So we're starting to get some cyclogenesis of a coastal low, otherwise called a nor'easter. And This is what happens in the upper levels, and this drives the system. It's what we call negative tilt. Here's neutral tilt, positive tilt, negative tilt. You can see that this is now into a negative tilt situation. So that's what spins up our nor'easters, and that's what makes our nor'easters so common. It's exactly what reached out, if you will, and reached out and caught Sandy and caused Sandy to hook into New Jersey, making that very sharp left turn. So consequently, same kind of mechanism here, only this is not a tropical system. This is just a plain old, good old-fashioned nor'easter, but something that is very significant. Looks like the upper level low cuts off here. It's fairly deep. This is relatively new, and I'm showing you the European model, by the way, which is pretty accurate, and it's this is the operational mode. But you can see that it's a fairly significant trough, and the jet stream energy cuts off, and you got this big broad ridge. What happens in the west is also interesting. California, Pacific Northwest is also going to be affected by a pretty strong storm as well. And looks like as time goes on, that coastal low goes off the coast here. This is valid time next Saturday, a week from today. But look what's incoming here. Very strong jet stream energy for the west coast of the United States. That's going to be very significant. Very heavy mountain snows likely, along with colder temperatures and fairly significant rains along the California coast as well. Now, also I want to call attention real quickly to the wind fields, and I found this to be fairly alarming simply for the fact that areas right now across New Jersey, really Virginia, Maryland, right up into New York City, Long Island, into parts of eastern Massachusetts, certainly Connecticut. This is a very significant situation here. If you'll notice that this is the wind field here, and no problems here yet. We're talking now we're into Sunday. We got a northwesterly flow across the eastern part of the northeast part of the U.S. But what's going to end up happening is we're going to see that area of low pressure begin to emerge. This is the lead shortwave. It's exiting out of the region. This is valid Monday at 2 o'clock in the afternoon, actually 1 o'clock in the afternoon, as we change over to Eastern Standard Time. Okay, let's get that nor'easter spun up. There it is right here. It's in the northern panhandle area. Got a very strong, significant, fairly good winds of sustained winds. You're talking 18, 23, 28 miles per hour off the Gulf Coast. Keep an eye on that and watch what happens once we get it south and east of the Carolinas. There's your area of low pressure. It's hugging the coastline in this particular track. Again, this is the 0Z operational European overnight. As it gets into the around the vicinity of Cape Hatteras, North Carolina, we're going to see the wind fields begin to increase significantly, and already you're starting to see sustained winds getting in the 35, 40, maybe even a touch of 40, 45. And right now, that's of course we're talking Delaware, Maryland coast, the southern coast of New Jersey starting to be affected. This would be a valid time of 10 a.m. on Wednesday. So 10 a.m. on Wednesday, the day after the election. Look at this. We have very significant winds now. We're talking sustained 40, 45, almost 50 miles per hour. These are not gusts. This is significantly sustained winds. It's very concerning. There's no dunes left in many parts of New Jersey. This is a bad situation, about to get worse. I want to also show you how the storm will track up the eastern seaboard. You notice that it weakens, but it does affect the entire coastal areas all the way up into down east Maine as well as Nova Scotia. Those are the wind fields. Let's check the barometric pressure and compare notes from the 12Z and 0Z model runs. This is the European model as well, and what we're going to do is we're going to start real quickly, and we're going to take this you're going to see an exiting storm system. This is the one that's currently affecting us. Actually, it's the remnants of Sandy. And you see that it moves out to sea, okay? Quick geography here. This is obviously Vermont, the Northeast. Keep your eyes on Florida. We're going to go through some time here. Okay, right there. There's your little pinpoint dot. And this is where the European model thinks that the very significant nor'easter will just begin. This is 90 hours out. This would be valid time 18Z. That would be 1 o'clock on Tuesday of the election day, which will probably mean quite a bit of rain for the southeast United States and Florida. Keep an eye on that and watch this. Now this is a comparison. Now the black is 0Z European model. The red is the 12Z, yesterday's European model, the last model run, and the blue is the American's GFS model. And you will see that there's some discrimination here, some differences, where the GFS is a little further out to sea. Let's just keep a track on that and see where that goes. Okay, again, this would be valid time. Now we're talking, let's see, 108 hours. That'd be 12Z, so that'd be 7 o'clock in the morning on Wednesday. You see the system blows up. It's undergoing what we call bombogenesis at 120 hours. Now, notice the red and the black lines are lined up. The American GFS is a little bit ahead. Notice that it's already pushing through and already into the vicinity of Cape Cod. Now, at 126 hours, we're going to see that that difference. There's your red and black pretty much centered, meaning the European operational model runs are on top of the situation. The American GFS is still opening things into a longer wave trough, but overall, the models are in similar agreement, with the European being a little bit stronger, a little bit closer to the coastline. And so you can see how the trends work here. So what does this mean? Well, let's check the snowfall situation here. Here we'll backtrack a little bit. Okay, this would be valid time 18Z. And what I want to show you here is how the snow will develop. Now this is snowfall. So you'll see it develops in the interior sections of Virginia, West Virginia. Same place, West Virginia, it looks like that got hit earlier. And then it develops into the interior sections of New England. Take a look, Vermont. This is how it will shift up and across the region. Most of this action will take place in the dark, meaning the temperatures will be at its coldest levels. Snow is likely. Get your snow tires on. You've been warned. And there goes the heavier snow. Okay, that's it for now. This is a sort of a trial experimental run. Again, I'm Roger Hill of Wuthering Heights Consulting. Thanks for checking it out.